No. So what is the weight of the container? Weight of the container, weight of the liquid, WL, weight of the container, WC, density of liquid be this one. So what is the normal contact that will act here? So shall we write N1? So there's a ground or a floor. So what is the normal reaction in this case? Weight of the liquid, weight of the container plus weight of the liquid. Will I agree all of you? Okay, now I'm going to immerse a solid. I'm going to immerse a solid here now. Let's see what conditions will exist in this situation. So what is a solid? So I'm going to bring a solid object. So some arbitrary shape, need not be sphere. This one. So it is immersed. So let the density of this. Able to see the difference here. So there's a solid, I know it's volume of solid. Tell me what will happen to it. Some water will get spilled up, no? Here. So let this is solid. Volume of this solid be Vs. This one, it is fully submerged here. So then what are the forces that are acting? Weight of the solid. Then the buoyant force. Of course, the net force exerted by liquid on the solid, that only what will happen, the buoyant force, or you can call upward thrust. It is fully submerged. What is the state of the body? Solid is fully submerged here. Anything will happen to liquid. Some liquid will overflow, no? Some liquid will get displaced. Some liquid will get displaced here. And so if you want, you can show the same volume of that one. This is very important. Please do understand. Now we have plenty of good numericals based on this idea. So some liquid will displace. So what I should call this one is displaced liquid. No, this is. Now what is it? This density will be rho L. How much of what is the volume of this? Volume of the displaced liquid. Anybody? Should be equal to volume of solid only. So now also open, the vessel is fully filled. Now also vessel full. So now the normal contact which is acting, let it be N2. So what is the weight of the liquid? So shall we put WL dash, because some liquid got displaced. And how much it got this? So let's get to this one. So I'm interested in this N2 now. Now before that, what is the volume of displaced liquid? What to write this one? Shall I say it's equal to volume of solid only? What is VD? Volume of displaced liquid. And what is equal to? And Vs is what? Volume of solid. Okay, is it okay? Or no, sir, cannot happen. How much the solid immersed, that much of volume of the liquid will be displaced here. Will I agree this? So now what is N2? N2 we are going to write like this. Weight of the container, weight of the remaining liquid. Any other thing will you add? The buoyant force. So now you have to ask me a question. How come, sir, buoyant force you are going to write? How do the ground will feel that buoyant force? So let's come to the Newton's third law. The liquid will exert force on the solid. In turn, the solid will exert force on the liquid. So there'll be a buoyant force by Ohm, by the liquid, by the solid on the liquid. So what is this? What is this FB? This FB is by the liquid on the solid. What is this FB? By the solid on the liquid, it will be acting downward. So therefore, I have to add that FB here. I'll put in red color so that it'll be easy for you. Okay, now what is this buoyant force? So let's go for the buoyant force definition. This should be equal to density of liquid, volume immersed into G. In fact, how much of volume immersed? The total solid is immersed, no? So shall we write here Vi equal to Vs? Any reason for that? Because solid is fully submerged. Able to notice that one? Solid is fully submerged. So therefore Vi equal to Vs. So therefore I'll write it as rho L Vs into G. What is rho L into VSG? Rho L Vd equal to Vs. So this is nothing but equal to, shall we write here rho L Vdg? And what is rho L Vdg? Weight of I think this is what Archimedes principle. Huh? So there's a weight of displaced liquid. So another method of calculating buoyant force. Just calculate the weight of displaced liquid. Why do the liquid get displaced? I think there's a natural. This happens, I think, if you're taking, like if a bucket is there, if you fully fill it up, just open to take the mug, or if you just put your hand into that, some water will overflow, no? Why did it overflow? Yes, because if you're when your part of a body gets into the water, some liquid should get displaced, no? Because it is fully filled. So therefore, one more definition for buoyant force, weight of the displaced liquid. Okay, let me write that one now. N2 is equal to WC plus WL dash. So shall we write in place of buoyancy as rho L VdG? Now what is rho L VdG? The weight of the displaced liquid, WC plus WL dash plus WD. What is the WD means? Weight of displaced liquid. So then, so what is the total WL should be equal to? According to this, what is the WL should be equal to? WL dash plus WD. So that WD, shall I write it here? I think I'll make capital letter. Huh? This is, yeah. So WL, what is WL? WL should be equal to, somewhere we'll write it here. Okay, let me put it all the things. So how much we're getting N2 equal to WC plus the same thing, no? So therefore what we get finally. This is something very important. What is the reaction by the, so what is the reaction by the ground on the container? It will be same. So finally what happened? We ended up with one equation called like the buoyant force. In some cases, we don't know volume. We can't measure everything all. So we are able to measure the weight of displaced liquid. So I'll take help of in that way. Okay,